Stealth is not a material. It is a system, geometry, surface treatment, and electronic management, whose collective effect reduces a platform's electromagnetic signature below detection threshold. Remove the surface treatment, the radar-absorbing material that converts incident radar energy into heat rather than reflecting it, and the geometry alone is insufficient. The angles still deflect energy, but the residual energy those angles cannot deflect is now reflected rather than absorbed, pushing the platform's radar cross-section into a range where capable radars detect it. Stealth without its coatings not invisible. It is merely harder to see. In the operational calculus of contested airspace, that difference is the difference between survivable and not. The Iranian Air Force and IRGC Air Force had been pursuing stealth capability for over a decade. The pursuit was publicly acknowledged through prototype aircraft whose aerodynamic shapes incorporated stealth geometry. Acknowledged because visible shapes alone were not the strategic concern. The concern was the surface treatment. Radar-absorbing materials require sophisticated chemistry, whose production demands precursor chemicals, specialized processing infrastructure, and quality control that cannot be improvised from commercial industrial chemistry. If Iran had developed domestic production capability for militarily credible stealth formulations, the prototypes became something different. Platforms waiting for their surface treatment. Platforms waiting for surface treatment have a timeline that is not indefinite. The facility that the target folder described had been operating for 7 years by the time the collection had characterized it with sufficient precision to support a targeting decision. It was underground, in the desert highlands east of Yazd, at a depth and in a geology that the Iranian program had selected for the specific environmental requirements that radar-absorbing material production imposes. Stable temperature, controlled humidity, isolation from the vibration that industrial processes in surface facilities inevitably generate, and that compromises the precision chemistry of ferromagnetic particle dispersion into polymer matrix systems. Those requirements pointed to underground construction in a geologically stable desert formation, and the desert highlands east of Yazd offered the most suitable combination of geological stability, isolation, and proximity to the transportation infrastructure that raw material delivery and finished product distribution required. The facility had been built where the production requirements said to build it. The intelligence collection had found it where the production requirements said it would be. The production output, cross-referenced against finished material movements at the facility's disguised surface access point over 7 years, was consistent with coating between 4 and 6 airframes per year. That rate across 7 years, combined with the prototypes the imagery had been tracking, represented the threshold at which the Iranian stealth program transitioned from research and demonstration to operational acquisition. The threshold had been crossed. The targeting decision followed. The depth of the primary production chambers was 52 meters in the consolidated desert sandstone that underlies the Yazd Plateau, a formation whose density the geological survey had characterized as consistent and uniform, without the karst variability of the Gulf Coast targets or the silty layering of the Semnon Formation. Yazd desert sandstone was well cemented. Dry, the low water table of the central plateau meant the formation had never experienced the groundwater movement that creates the density variations of wetter geological environments. And predictable in the way that desert formations whose chemistry has been stable for millennia are predictable. The weapons engineers had assessed the fusing solution at 91% confidence. 9% was documented. The mission was authorized. The specific challenge was chemical, not geological. Radar-absorbing material contains ferromagnetic particles, iron-based compounds dispersed in polymer matrices, not conventionally hazardous. But a GBU-57 detonation inside a chamber containing large quantities of ferromagnetic stock in polymer suspension would produce a thermal event generating secondary reactions whose energy release was non-trivial, whose atmospheric products, iron oxides, polymer combustion byproducts, would be chemically detectable at the surface for days. The surface chemical signature was assessed as acceptable. It would confirm the facility's function to any nation conducting post-strike analysis, which was not a mission constraint. The secondary energy release was the engineering variable. Combined with the weapon's primary detonation, the total energy budget exceeded the standard kill mechanism model for conventional industrial facilities. More comprehensive elimination. The planners noted it as a benefit. More comprehensive elimination was not a problem. The mission planners had noted it as a benefit and had adjusted the expected post-strike characterization accordingly. The production equipment, the particle synthesis reactors, the polymer mixing systems, the quality control instrumentation, would not survive the combined detonation and secondary reaction energy. The finished material stockpile would not survive. The raw material inventory would be chemically altered rather than dispersed. The facility would be eliminated. The secondary energy release was, in the planner's assessment, a kinetic multiplier rather than a complication. The two B-2 spirits lifted off at 10:08 p.m. and 10:16 p.m. Two aircraft, because the facility's layout included a secondary formulation laboratory 41 meters from the primary chamber, housing the research function and quality control testing infrastructure, whose elimination prevented future reconstitution at any replacement facility. The lead aircraft addressed the primary chamber. The trail aircraft, arriving 7 minutes and 44 seconds after the lead's weapon employment, addressed the laboratory, an interval longer than previous packages because the ferromagnetic secondary reaction energy would generate seismic persistence that required additional clearance for the second weapon's GPS solution integrity. The routing to the Yazd plateau required 13 hours and 19 minutes. The central Iranian plateau's defense network had been built against threats approaching from the borders rather than transiting through the center. A Gulf approach turning north through the interior was not the architecture's primary design scenario. Coverage against that vector was real and thin. The EW package benefited from the most favorable geometry of any mission in the series. Growler flights at ranges, producing close to optimal jamming geometry for the S-300 batteries the aircraft would need to transit. The planning noted it and did not take it for granted, sizing against full battery capabilities regardless. The first tanker contact at 2:33 a.m. completed in 16 minutes over the northern Arabian Sea. The second contact at 11:08 a.m. east of the Strait placed both aircraft at their final fuel states. The coordination protocol between the two aircraft had been maintained with the precision the sequential release timing required. The lead aircraft's mission commander tracked the differential throughout the flight. The trail aircraft's mission commander tracked it independently. Both arrived at the same number at every checkpoint. The number was within tolerance at every checkpoint. The EW package activated at 10:44 a.m. local time, 51 minutes before the planned initial point, the longest early activation window in the series, driven by the Central Plateau's geographic extent and the planning's assessment that Yazd sector operators, informed by any pattern recognition in the jamming activation timing of previous operations in the region, would benefit less from a shorter window than the EW architecture would benefit from the additional adaptive characterization time that 51 minutes provided. The Iranian operators in the Central Plateau sectors had been experiencing periodic EW exercises that the Iranian military conducted to maintain operator proficiency. The activation pattern for those exercises had been characterized by the collection. The mission's activation timing had been selected to fall within the variance of the exercise activation pattern, appearing to the operators who received it as plausibly another exercise rather than an operational EW package. The deception was not expected to hold for 51 minutes. It was expected to hold for long enough to delay the operator's threat escalation by the margin that the plausible exercise framing produced. The planning assessed that margin at between 8 and 14 minutes. The Yazd sector's air defense architecture was lighter than any previous target in the series, a reflection of the central plateau's lower strategic density by Iranian military planning standards. Long-range coverage came from a single S-300 PMU-1 battery positioned northwest of Yazd, oriented toward the western and northwestern approaches. Medium coverage was provided by an HQ-16 system, whose position the target folder had established from recent imagery. The inner ring consisted of a single TOR-M, one battery covering the facility's immediate approach sectors, and a Panzer S-1 that had been garrison positioned at the facility's surface access point following a security review 18 months before the mission. The plausible exercise framing held for 11 minutes before the Yazd sector controller, comparing the jamming pattern's activation characteristics against the exercise database and finding a statistical deviation that is trained pattern recognition flagged as inconsistent with exercise parameters, issued a sector alert at 10:55 a.m. 11 minutes inside the planning's 8 to 14 minute estimate. The sector alert elevated all systems to active search. The S-300 PMU-1's acquisition radar increased its scan rate. The HQ-16 transitioned from standby to active search. The TOR-M1 at the inner ring activated its fire control radar in a full search mode. The Panzer at the facility access point activated simultaneously. The simultaneous activation of 4 systems in active search mode produced the electromagnetic environment that the B-2's passive warning receiver classified, logged, and displayed within 4 seconds. The mission commander assessed the display. 4 active systems, all in search mode, none in fire control track mode. Active search without a track was the expected outcome of a sector alert in a heavy jamming environment. The systems knew something was wrong. They had not yet found what it was. He was 37 minutes from the initial point. 37 minutes during which 4 active search systems were looking for him in a sector where the EW package was maintaining suppression at the effectiveness levels the planning had established. Maintained suppression against active search produced the detection probability the planning had modeled. The detection probability was the one the mission had been authorized against. He continued. At 11:09 a.m., 23 minutes from the initial point, the S-300 PMU-1 produced a return at 29% detection confidence on the approach vector. The return was the first above-noise floor contact any system in the sector had generated in the 25 minutes since the sector alert activation, 29%. The battery's tracking processor flagged it as below the automated reporting threshold. The operator watching the display was operating under a sector alert at an active search scan rate in a heavy jamming environment. And a 29% return in those conditions was, by his training and his experience, consistent with a jamming artifact rather than a valid contact. He logged it. He watched for a second sweep return on the same bearing. The second sweep returned nothing above the noise floor. The tracking processor downgraded the 29% return to background. The operator continued his scan. At 11:14 a.m., 18 minutes from the initial point, The same bearing produced a second single sweep return, this time at 33%. Again below threshold. Again watch for a second sweep return. Again, the second sweep returned nothing. Two single sweep returns on the same bearing, 18 minutes apart. Both below threshold, both disappearing before a second sweep could confirm them. The operator reported the two-event sequence to his supervisor at 11:15 a.m. Two isolated returns, same bearing, non-consecutive, below threshold, assessed as probable persistent jamming artifact on this bearing. Monitoring continued. The supervisor received the report and looked at the bearing. The bearing pointed southwest, toward the Gulf, toward the approach direction that a transiting aircraft from the Gulf region would use. Two isolated below-threshold returns on a Gulf approach bearing during an active sector alert. His professional instinct and his doctrine produced the same assessment simultaneously. Not enough for engagement authorization, enough for elevated monitoring and inter-battery coordination. He directed the HQ-16 to orient its search toward the same bearing and compare its returns with the S-300s over the next 5 minutes. The HQ-16's reorientation toward the southwest bearing produced at 11:17 a.m. a return at 22% on a position consistent with the S-300's two previous returns, adjusted for the flight time between those returns and the current sweep, at a velocity consistent with a fast aircraft. 22% at the HQ-16, two prior below-threshold returns at the S-300, same bearing, velocity consistent position displacement. The supervisor had 3 independent data points from 2 systems that were geometrically consistent with a moving contact. He did not have a single data point above the engagement threshold on any system. He transmitted a non-standard intersector contact advisory to the Regional Air Defense Controller at 11:18 a.m. 3 below-threshold returns from 2 systems, same bearing, velocity consistent, assessed as possible but unconfirmed contact, requesting regional awareness. The Regional Controller received the advisory at 11:19 a.m. and issued a regional awareness notification, not an active alert, but the next level above a sector alert. The notification reached the S-300 PMU-1 engagement controller and authorized him to activate fire control radar on the southwestern bearing if the next acquisition sweep produced a return above 30% on the same bearing. The next acquisition sweep, at 11:20 a.m. and 14 seconds, produced a return at 32%. 32% exceeded the supervisor's authorized threshold for fire control activation by 2%. The engagement controller activated fire control radar at 11:20 a.m. and 22 seconds. The fire control radar came up on a bearing 2 degrees south of the acquisition track's projection, a targeting adjustment that the tracking computer had made based on the velocity-consistent position displacement between the 3 below-threshold returns. 2 degrees of fire control bearing error, driven by below-threshold acquisition data, produced a fire control radar that was searching 2 degrees south of the aircraft's actual position. 2 degrees at the ranges involved was a lateral displacement of approximately 4.3 kilometers. The fire control radar was searching 4.3 kilometers from the aircraft's actual position when the Growler EW officer, monitoring the fire control frequency activation, redirected maximum output to the fire control band within 6 seconds of the activation. The fire control radar's picture degraded within those 6 seconds. It had been active for 8 seconds before full suppression took effect. In those 8 seconds, it had swept the area 2 degrees south of the aircraft's track twice. Both sweeps returned nothing above the fire control acquisition threshold. The bearing error had placed the fire control search window in the wrong location. The 2 degrees that the tracking computer had miscalculated from below threshold acquisition data had been the aircraft's protection 2 degrees, 4.3 kilometers. The margin between the fire control radar's search window and the aircraft's actual position had been the accumulated error from 3 below-threshold acquisition returns. Below-threshold returns produce imprecise track solutions. Imprecise track solutions produce bearing errors. Bearing errors produce fire control radars that are looking at the wrong piece of sky. The aircraft was in the right piece of sky, and the fire control radar was looking at the wrong one. The Growler's suppression ensured it stayed wrong for the remaining time before the initial point. The initial point for the lead aircraft was at 11:22 a.m. The bay doors open. The primary production chamber's subsurface coordinate was the aim point, 52 meters below the Yazd plateau in the consolidated desert sandstone. At a depth, the fuzing algorithm had been computed to find precisely in uniform dry formation. The GBU-57 released. The aircraft corrected and turned onto the egress heading. Bay doors closed. The weapon's descent through the plateau surface and into the sandstone proceeded without anomaly. The formation was as the geological survey had characterized it: uniform, dry, consistent, no density variations, no voids, no layering transitions to adjust for. The fuzing algorithm ran its standard sequence against a deceleration profile that matched the model at every depth increment. The fuse threshold was met at exactly 52 meters, the design detonation depth, to within the precision of the GPS solution. The detonation occurred at 11:22 a.m. and 37 seconds, inside the primary production chamber, at the depth the kill mechanism analysis had computed as optimal for the combined weapon detonation and secondary ferromagnetic compound reaction energy. The secondary reactions began at 11:22 a.m. and 39 seconds, 2 seconds after the primary detonation, as the thermal environment created by the explosion reached the ferromagnetic particle stock in the particle synthesis reactor section of the production chamber. The iron-based compounds oxidized in the high-temperature environment with the energy release that the chemical engineers had characterized. The combined primary detonation and secondary reaction produced a total energy event that the seismic monitoring network would record as a 2.7 magnitude event, larger than any previous strike in the series, a direct consequence of the ferromagnetic secondary chemistry adding energy to the seismic budget. The 2.7 magnitude event was visible on every monitoring station in the central Iranian plateau. It was not ambiguous. It was not naturally occurring. It was the geophysical record of a chamber full of sophisticated industrial chemistry, encountering conditions it was not designed to encounter. The trail aircraft's initial point was at 11:29 a.m. and 44 seconds, 7 minutes and 7 seconds after the lead aircraft's weapon impact, within 37 seconds of the planned 7-minute, 44-second interval inside the seismic noise budget that the planning had established for the secondary weapon's GPS solution integrity. The secondary formulation laboratory's aim point was 41 meters from the primary chamber at 49 meters depth, slightly shallower than the primary chamber, consistent with the laboratory's position in a section of the facility that had been excavated at a different stage of the construction program. The second GBU-57 released from the trail aircraft's forward station and followed its terminal guidance to the subsurface coordinate. The fuse threshold was met at 48 meters, 1 meter above the design depth, within the tight confidence interval that the uniform formation's predictability had produced. The laboratory's research infrastructure, its quality control testing equipment, the formulation databases and material specification records that a decade of radar-absorbing material development had accumulated, everything required to reconstitute production capability at any future facility. was eliminated at 11:29 a.m. and 51 seconds. At 11:23 a.m., the facility's surface monitoring station had registered the primary detonation's seismic signature and had attempted contact with the underground complex on all communication channels. Silence. The duty officer had activated the emergency protocol at 11:25 a.m. By 11:30 a.m., when the second seismic event from the trail aircraft's weapon reached the surface monitoring station's instruments, the duty officer's report had already been transmitted to the facility commander. The facility commander's report to the IRGC Air Force Command was transmitted at 11:34 a.m. By 11:34 a.m., the lead aircraft was 180 miles into its egress and the trail aircraft was 70 miles into its own. The chemical signature at the surface above the primary chamber appeared in the atmospheric monitoring data from regional environmental stations at 11:51 a.m., iron oxide particulates and polymer combustion byproducts at trace concentrations above ambient, drifting southeast on the desert wind. The concentrations were below any threshold that civilian environmental monitoring would have flagged as significant. They were above the threshold that the collection program monitoring the Yazd facility's atmospheric environment had been calibrated to detect. They were detectable for 4 days. They confirmed, to any analyst with access to the monitoring data, the function of what had been inside the chamber. The confirmation was unnecessary for the targeting decision, which had already been made and executed. It was useful for the post-strike assessment, which could now characterize the facility's elimination with a confidence that the physical collection alone would have required weeks to establish. The numbers that closed the package: 13 hours and 19 minutes of flight time for the lead aircraft, 2 GBU-57 massive ordnance penetrators employed from 2 aircraft in a 7-minute, 7-second sequential interval, 3 below-threshold S-300 returns and 1 HQ-16 return, producing a velocity-consistent track that triggered fire control radar activation, 2 degrees of bearing error from the accumulated below-threshold tracking imprecision, placing the fire control search window 4.3 kilometers from the aircraft's actual position, 6 seconds from fire control activation to full Growler suppression, 8 seconds of active fire control operation, finding nothing before suppression took effect. Detonation at exactly the design depth of 52 meters. The only mission in the series where the fuzing solution found no geological anomaly. Secondary ferromagnetic compound reactions producing a 2.7 magnitude seismic event, larger than any previous strike. 0 aircraft lost. Primary production chamber eliminated. Secondary formulation laboratory eliminated. The radar-absorbing material production capability that had been coating Iranian stealth prototypes for 7 years, preparing them for the operational transition from prototype to platform, was gone. The geometry of a stealth aircraft can be designed without the surface treatment. The surface treatment cannot be produced without the production facility. The facility cannot be rebuilt without the formulation database that was inside the laboratory. The laboratory is gone. The prototypes that were waiting for their coating will wait longer, in an indefinite condition that is the operational equivalent of the question mark that stealth without surface treatment represents on a radar scope. The desert holds its seismic record. The plateau above the chamber is unchanged. What it was concealing is not.